All right, we're going to go over how to take care of Geometry Practice Test 6.1. Classifying by angles. So just remember, you want to look for, is it obtuse? In other words, the angle is greater than 90. Is it actually a right angle, which would be equal to 90? And if at any point you find a right angle, you can stop there. If at any point you find a right angle, you can stop there. And if all of the angles are less than 90, if x is less than 90, then you're dealing with an acute, right? So these are going to be our three main choices: obtuse, right, and acute. So looking briefly at the diagram, you can see that yes, there is an acute angle, but there's a right angle. And as we said, that's going to trump everything. So this is a right triangle. All right, classify by the sides. So we're looking for these situations. Are there two sides that are the same? That's an isosceles. Are there three sides that are the same? That's a equilateral. If you don't have those memorized, you need to. Are there no sides the same? Then that's a scalene. And you can see none of the sides are the same. 7, different than this, different than this. So, scalene. Find the exact distance. Okay, you can use Pythagoras theorem. You could plot these out on a grid. 1, 6, 2, 8, and find the spacing that makes that hypotenuse. But let's use the distance formula directly. Okay, x2 minus x1. You do need to remember this. This is from Target 1, but review questions, including specifically this, will be on all the tests in semester 1. So the formula: x2 minus x1 plus y2 minus y1. We got a lighting issue here. That's no good either. Okay. I recommend labeling these x1, y1, x2, y2. Just quickly set it up. 8 minus 6 squared. 2 minus 1 squared. 1 squared, 2 squared, 4, 1 is equal to the square root of 5. That is the exact answer. That is the exact distance. How to find the approximate distance now? Well, just put the square root of 5 in a calculator if you want, or you can estimate it. But the square root 5 square root of 5, approximately 2.23. And that's what it's referring to with the approximate and the exact. All right, classifying by angles. We already talked about the fact here we have three angles that are the same. That's equiangular. Check your graphic organizer. You should know all the terms on it for the different classifications that have been given. Classify by sides, all three are the same. That is equilateral. Remember that word lateral means side. We use it in football. Okay. Problem 4. Give them the coordinates for the points. Okay, let's plot those points. Always plot them. S, T, which of the following would be coordinates for A so that it's a right isosceles? So to be a right triangle, either that's going to come this way or this way. Okay. And to be isosceles, because I'm making a right angle between these, to be isosceles, then if this is 3 units, which it is, this spacing's got to be 3 units. Okay? So this would be a great option. This is a right isosceles. So 1 over 2 up. There it is. Now, this could also, just to point out, this could also make a right triangle. But that coordinate point 4, 2 was not an option. Okay? So, just have to draw that one. All right, classify following triangle by its sides. Measure of M, I, and R. Just draw yourself a generic triangle. Label them M, I, R. M is 45. Great. Let's put that down. I is 90. Okay? And R is 45. Right away you should notice these angles are the same. Therefore these sides are the same. Therefore it is an isosceles. By the angles, we would go ahead and say that it is got two acutes and a right, so we're going to call this a right triangle. This is a right isosceles, okay? Classify the following triangles by its angles and sides. All right, well, it's on a grid, so let's count the lengths, right? That's 1, 2, 3, 4, 5. That's a 5. Now, you may, we could find these lengths, all right, using Pythagoras theory. I could say, well, it's a 2 by 1, 2, 3, 4, 2 by 4, and I could use Pythagoras theory. 2 squared plus 4 squared equals c squared, which would be this side. And of course that's 4, it's 16, and equals c squared. That'd be 20 equals c squared. And so I could say the square root of 20 is this side length. And you know, I could also do it to this one. This is a 2 by 1 triangle here. So 2 by 1. Okay, well. Okay, square root of 5. But even if I hadn't done that, I'm sure you can simply notice that this length is different than this length. And they're clearly different than this length. So we have 1, 2, 3 different lengths. That's scalene. By the angles, nothing's been marked. So do not assume that this is a 90-degree angle. In a complex problem, if it said calculate the angles, okay, we could go through and find out if it is or not. But in this case, we're going to assume that nothing here has been labeled as 90 and that it's not. This is clearly acute. This is a different angle and it's clearly acute. This is probably just less than 90, so I'm going to say it's acute. It could be obtuse. This one's slightly questionable given the information you have. We have to do a little bit of work that's beyond the scope of your knowledge right now as far as calculating that exact angle at this moment in time. Right. Select the responses that correctly complete the sentence. Given triangle ABC, 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, there's A. Point B, there's 2 by negative 2. B. C, 5, 6, 7, negative 1. How is it classified and why? Okay, well, the first thing that is probably noticeable to me as that 7, negative 1, and this is what? 2, negative 2. So let's find the distance here to here. That was a 5 over and 1 up difference. And from here to here, which is, this is at 5, 4. That makes this a 5 altitude change here, and 2. Let's check here. This went from negative 2 to positive 4, so that's 6 rise and several over. Okay, so none of these are the same ratios. None of these are the same length. You know, they look similar, like it could be isosceles, but it's not. So I'd have to say it's scalene, and so all three sides are not congruent. It says all three sides are congruent. Two of the sides are congruent. Very close, but not. We said it's scaling because no two sides are congruent. All right, let's move on to test 6.2. Let's zoom back a little bit. Okay, we're going to start the target 6.2 practice test answers, and I just want to point out that you can highlight these things. I would really recommend it. Let's take note of things like, oh, this side and this side are equal. That makes this a midpoint. All right. Here's your answer key. I've highlighted. So AE came out of the vertex to the midpoint. That's a median. Okay. Labeled it with C. EF, right? That's also out of the midpoint, but it's perpendicular. Well, if you cut the midpoint perpendicularly, that's a perpendicular bisector. We're cutting this segment into two equal halves. AG, drop from the highest point, boom, hits the ground perpendicularly. That's an altitude, so that's A. And then CD, we've got the markers for the two angles being the same, so we bisected the angle. You just got to purely memorize this stuff. Let's start at the bottom. Orthocenter Altitude. I talked about you have to have a way to memorize things, like I say OA, AO. Okay, it's like a Brooklyn thing, but that remembers to me orthocenter and altitude. The centroid reminds me of metroid, which starts with an M, just like medians. Okay, the incenter, the intersection of angle bisectors, bi-in, okay, and circumcenter, perpendicular bisectors, okay. Moving on. Okay, we need to remember a rule here about this. We need to remember that if you have a mid-segment, all right, in other words, it goes from the median of this side to the median of this side, and it's parallel, it is parallel to the base of the triangle, then this relationship is always set up where it would take two of these to equal one of those, okay? Two of the short one to equal one of the long one. All right, the short one is DE, and it tells you that it's got some sort of congruent relationship, that it is the same measure. Is that true or false? Well, no, they're not the same measure, okay? That's not true. D is the midpoint of BA. Well, yeah, that's true because it told us DE is a mid-segment line, and by definition of a mid-segment, it's going from midpoint to midpoint. Now, DE is 5, all right? We like to label things, so 5, this is BH is 3x minus 7, solve for x. Well, a lot of kids want to say, oh, they're equal to each other. Well, you're close, but that's not true. Look again, they're obviously not the same size, and we just said it takes two of these to equal one of those. That's always going to be the case when you have these parallel lines between a mid-segment and the base. So, two of those is equal. All right, well, that means 10 is equal to 3x minus 7. Add 7. I get 17 equals 3x. Okay? Divide by 3 on both sides. Divide by 3 on both sides. Well, that's where you're going to, get kind of a decimal or a fractional amount. Okay, because you could say 3 goes into 17. Well, 5 whole times with 2 left over. Okay, 5 2/3. That's the answer. X is 5 2/3 or 5.6 repeating, approximately. Okay? But that's what I'm looking for when it says solve. You're given the diagram below. Explain why DE must be a perpendicular bisector. DE must be a perpendicular bisector because 1, 2, 3, 1, 2, 3. So it is D is the midpoint of AC and is perpendicular. It may seem obvious, but you just need to be able to do something that mathematically proves that your point. DE is a perpendicular bisect, then DE must bisect AC. All right, they're just setting that up. We've said so. Provide support to show that DE is a bisector. You know, we've done it because 3 units, 3 units. AD, segment AD is equal to 3. Segment DC is equal to 3. Therefore, AC equals 6, and point D is in the middle. All right, you know, something like that. All right, construct the perpendicular bisector of AB. B, it's 6 units, so there's the center. Perpendicular bisector has to go perpendicular, so done there. Construct perpendicular bisector of AC. 8 units, 4 must be the center. Done. You can determine the location of the circumcenter by looking at the intersection of 2 segments you've drawn. Yeah, because circumcenter is perpendicular bisectors. So what are the coordinates of the circumcenter? It's where they cross. Okay, so 4, 3. 4 over, 3 up. And that also means that this distance, and this distance are the same. And that you could draw a circle, if I had a compass, could draw a circle that's perfectly circular around, centered on that point, with these as the radii. Okay? That's it. Good luck. Peace.